Hello students, good morning. So in the last videos I explained regarding the organic chemistry topic, haloalkanes and halogens. So there we studied regarding the topic haloalkanes, halogens. What are haloalkanes? How are they classified? Preparation of haloalkanes, then properties of haloalkanes, their mechanisms, even applications are told. And in halogens also same type, preparation, properties, applications, mechanisms, etc. Then in next topic there is alcohol phenol ether. Unit 11 is inside book they mentioned Unit 11. So in theory paper we can expect in theory paper 7 marks. Theory paper 7 marks. In part B 2 mark question, and in part D 5 mark question. In part D it may be 2 to 1 mark or 3 and 2. It's total 5 marks in part D. So anyway 7 marks weightage in theory paper. And in CET you can refer previous year papers. In some papers they may ask only what 2 marks, and in few papers 4 questions. Maybe 2 to 4 questions in CET. But in NEET JEE 1 question. This is one of the important topic, alcohol phenol ether. So today we study mainly regarding the alcohols. So first I will tell you what are alcohols, then classification, properties, etc. and also their uses. Alcohols. If organic molecule contain hydroxyl group, if it contain hydroxyl group, which is linked with sp3 hydroxyl group linked with sp3 hybridized carbon, sp3 hybridized carbon, then only the molecule is said to be what? Alcohol. Then we can define what is alcohol. Alcohols are the derivatives of hydrocarbons. They are obtained by replacing one or more hydrogen atoms of the hydrocarbon by what? Hydroxyl group, or we can say hydroxy derivatives of hydrocarbons in which one or more hydrogen atoms of hydrocarbon replaced by hydroxyl group. Then the hydroxyl group linked with what? sp3 hybridized carbon or saturated carbon, and such compounds are called alcohols. And in alcohol, see example CH3OH, CH3CH2OH. Just you see groups methyl, but these groups are obtained from alkane, and alkane general formula actually CnH2n plus 2 is the alkane. But hydrogen atom of alkane replaced by hydroxyl group. Hence the general formula of alkane, alcohol says what? CnH2n plus 1 OH. Or we can write this group as alkyl group, and alkyl group are general formula of alcohols ROH or CnH2n plus 1 OH. Okay, repeat definition of alcohol: hydroxy derivatives of hydrocarbons in which the hydroxyl group directly attached to sp3 hybridized carbon, or saturated carbon, they are said to be alcohols. Then examples: methyl alcohol, ethyl alcohol, etc. And afterwards I will tell you how to classify alcohol and how to study on these compounds. But now see application of these. What is the use of such molecules, alcohols? So in general, in paper, this paper is made up of a polymer cellulose. Cellulose is a polymer of what? Glucose, and glucose contains hydroxyl group. C6H12O6, that is the molecular formula, but they contain hydroxyl group. Therefore, paper is made up of hydroxy compound. Then similarly, even other examples you can take, like alcoholic beverages. Heard about alcoholic beverages? Beer, brandy, whiskey, which contain what? Ethyl alcohol. Ethyl alcohol is used in the manufacture of alcoholic beverages such as beer, brandy, whiskey, and they contain what? Hydroxyl group. There is a case of what? Alcoholic beverages. Even we can use ethyl alcohol in hospitals. As antiseptic agent, Then even ethyl alcohol we can use as solvent for oils, fats, resins, etc. Oils, fats, resins. And to manufacture esters or perfumes, one need what? Alcohol such as methanol and ethanol. Then ethyl alcohol. So one can use to prepare what? Acetic acid. Further, it is named as vinegar. That is prepared by using ethyl alcohol. Then methanol as antifreeze in automobile radiators. And methyl alcohol also used to prepare methyl salicylate. That is called oil of wintergreen, and which can act as what? Analgesic agent. That is prepared by using methanol. And methanol also used to denature ethyl alcohol. Hence, ethyl alcohol is made unfit for drinking by mixing with methanol. That is to denature ethanol. Yes, we are using methyl alcohol or methanol. Like this, we can say many applications of alcohols. Maybe methyl alcohol, ethyl alcohol, glycerol, benzyl alcohol. Many alcohols are there. Okay, but they contain hydroxyl group. If you consider methane, ethane, property of methane, property of methyl alcohol, completely different. Difference is only one H in place of OH, but the property is different. This alcohol, liquid, ethyl alcohol, liquid, but methane, ethane, gases. And these are insoluble water, but these are soluble water. Means that shows all the properties, almost properties, they are different compared to what their corresponding hydrocarbons. Next, now we can study how to classify alcohols. Based on the number of OH groups, we can classify alcohol into different types. They are monohydric alcohol, or dihydric alcohols, trihydric alcohols, and polyhydric alcohols. Classification of alcohol. Monohydric, dihydric, trihydric, and polyhydric. They depend upon number of OH groups. If alcohol molecule contains only one OH group, it is called monohydric. 2 OH groups, dihydric. 3 OH, trihydric, and more than 3 OH comes under polyhydric alcohols. Monohydric alcohol example: CH3, CH2 OH. This is called ethyl alcohol or ethanol. Dihydric alcohols: CH2 OH, CH2 OH. And this compound named as ethylene glycol. This one, ethyl alcohol, ethylene glycol. Trihydric alcohols: CH2 OH, CH CH2 OH. This is called glycerol. Monohydric, dihydric, trihydric, and polyhydric: CH2 OH, CHOH 4 times CS2OH. Actually hexol, 6 OH groups are hexol. Then its name, common name, what? Sorbitol. Sorbitol. So in the nomenclature, I will cover how to name the compounds according to common name and IUPAC name. Okay. Then now in a common system, see how to name such compounds. Common system as alkyl alcohol. As alkyl alcohol in a common system, which is monohydric alcohol. Then now IUPAC system, you will use the suffix "ol." Suffix "ol," and they are named as alkanol. Named as alkanol. This last ending E of the corresponding alkane replaced by suffix OL. Alkanol. If it is one carbon compound, methanol. 2 carbon with 1 OH group, ethanol. 3 carbon OH at carbon number 1, that is said to be propane-1-ol. Like this, we'll study afterwards a list of the compounds. Anyway, this compound contains 2 carbon, ethane. And for OH group, all, therefore, ethanol. Ethane. The ending E replaced by OL for alcoholic group. Therefore, it is called ethanol. Ethyl alcohol, common name, ethanol IUPAC name. Similarly for CS3OH, methyl alcohol, common name, and methanol IUPAC name. Next, dihydric alcohols. Dihydric alcohol, common name, ethylene glycol, IUPAC name, ethane 1,2-diol. Ethane 1,2-diol. So here you write complete ethane 1,2-diol. Ethane 1,2-diol. Here you have to retain E, but don't write ethane diol 1,2 or 1,2 here diol. Ethane diol. No. This is the correct nomenclature of ethylene glycol, ethane 1,2-diol. Similarly for this, glycerol 1, 2, 3. Propane 1, 2, 3 triol. It is called propane 1, 2, 3 triol. All triol. Next, sorbitol IUPAC name, 6 carbons, 1 to 6. Therefore, hexane 1, 2, 3, 4, 5, 6 hexol. Not hexanol, it is hexol. Hexane 1, 2, 3, 4, 5, 6 hexol. So this is the classification of alcohol based on number of OH groups. Next, monohydric alcohol we can classify further. Yes, based on the nature of carbon. If hydroxyl group linked with a carbon atom which contain 2 hydrogen atoms or 1 alkyl group, 2 hydrogen atom or 1 alkyl group, and such compounds named as primary alcohol. Next, if hydroxyl group linked with CH or 2 alkyl groups, CH links with 2 alkyl group, then it is called secondary alcohol. Last, if hydroxyl group linked with a carbon which do not contain hydrogen or linked with 3 alkyl groups, then such compounds are said to be tertiary alcohol. You write formulas. But about primary, secondary, tertiary, primary carbon, secondary carbon, tertiary carbon, and all these I explained in what halorcane topic in detail. Okay, there I used the X atom linked with carbon. But here hydroxyl group linked with carbon. Classification of alcohols based on the nature of carbon. That is primary alcohol, secondary alcohol, tertiary alcohol. Primary alcohols, secondary alcohols and tertiary alcohols. 2 degree, 3 degree. Primary alcohol, secondary alcohol and tertiary alcohol. See the functional group of primary. CH2OH, CHOH, COH. Functional group of primary alcohol, secondary alcohol, tertiary alcohol. And make it general structure, general formulas. Here only 4 bonds, 1, 2 plus 2, 4. RCH2OH, primary alcohol, 1, 2, 3, 4, right. R and R dash. RCH, R dash, OH. Second alcohol, R dash, R dash. Tertiary, primary, secondary, tertiary. And even now we can write in short. RCH2OH, R2CHOH, R3COH. In short also we can write this RCH2OH, R2CHOH and RCH2OH, R2CHOH and R3COH. Yes, these are the general formulas. Then examples, just to write R equal to methyl group or here R equal to hydrogen. If it is hydrogen, yes, methyl alcohol. Then R equal to CH3, ethyl alcohol. Similarly for other. You see here examples under primary, secondary, tertiary. Primary alcohol CH3, CH2OH. Secondary alcohol CH3, CHOH, CH3. Or you can write CH3 here, OH here. But group must be OHCH. That is the secondary alcohol. Primary alcohol, secondary alcohol. Tertiary alcohol CH3C, CH3OH. So importance given to OHCH2 primary alcohol, OHCH secondary alcohol, OHC tertiary alcohol. Now common names I will tell you in list. I will give you common name names. Common name of this one ethyl alcohol, second isopropyl alcohol, and third tertiary butyl alcohol. Tertiary butyl alcohol. These are the common examples in case of primary alcohol, secondary alcohol, and tertiary alcohol. Even other examples are there, and then we study afterwards. So this is about how to classify alcohol based on the what nature of carbon, and even nature of what type of hybridization. Also, we can study classification. They are called allylic alcohols, vinylic alcohols. In case of allylic alcohol, CS2 double bond CH, CH2OH. You know this group. CH2 double bond CH, CH2. This group is named as allylic. And now we can change even this one. These two H replaced by any group, RR, phenyl group, hydrogen atom, and here also same. So important OHC immediately linked with what? Linked with the C double bond C, and such group named as allylic group. Then OH group linked with C, then to what? C double bond C, and such compounds are called allylic alcohols. Example: CH2 double bond CH, C double bond CH2 OH. So in yellow alkanes they are told numbering from double bond 1, 2, 3 chloro, prop 1 E in there I told. But now importance given to OH, not to double bond, because in functional group priorities, yes, we know how to write the name and with the numbering. OHC 1, 2, 3. Now it is named as pro 2 in 1 on. Pro 2 in 1 on. Common name allyl alcohol. It is called allyl alcohol. IUPAC name pro 2 in 1 on. There is 2-propenol. That also we can have 2-propenol. Okay, important molecule, allylic alcohols. Okay. Similarly, benzylic alcohols. Benzyl group, you know, allylic kind of benzylic. Benzylic also comes under sp3 carbon. See here, OHC, sp3. Even in benzylic, sp3. Benzene ring, C OH. Ring COH. This group named as benzylic group. It is called a benzylic group. Next, I can write here HH, benzyl alcohol, primary alcohol. Primary alcohol. If I write here R, methyl ethyl, secondary alcohol. One more R group, tertiary alcohol. Therefore, in benzylic alcohol, 3 types: primary, secondary, tertiary. Allylic alcohols also 3 types. If OHCH2, primary alcohol, OHCH, secondary alcohol, OHC, tertiary alcohol. Therefore, allylic alcohols 3 types: primary, secondary, tertiary, and benzylic alcohol 3 types: primary, secondary, tertiary. If you know clearly about primary, secondary, then you can identify which compound is said to be primary alcohol, secondary alcohol, and tertiary alcohol. Now you can study nomenclature of alcohols. So in nomenclature, there are 2 types. That is common system and IUP system. According to common system, we can name alcohols as alkyl alcohol, alkyl alcohol. And according to IUP system, common system, monoacidic alcohols named as alkyl alcohol, and IUP system, yes, alcohols are named as, or monoacidic alcohols are named as alkanol. Now I will give you list of compounds with common name, IUPAC name, all are important for practice well there. First one, simplest alcohol, CS3OH. Second, CS3CH2OH. Third, CS3CH2CH2OH. Fourth, CS3CHOH, CS3. So simple what monoacidic alcohol molecules and their common names as alkyl alcohol. Yes, CS3 methyl, OH group alcohol. Second, C2H5, CS3CH2 equal to C2H5. C2H5 name ethyl, then OH alcohol, methyl alcohol, ethyl alcohol. Next, 3 carbon. See here, 1, 2, 3 carbons. From carbon 3 onwards, that is in alcohol series, N-propyl alcohol, isopropyl alcohol, N-propyl isopropyl. So these 2 compounds exhibit isomerism because these 2 have same molecular formula and they differ by position of OH group. Here get carbon number 1, that is OH group, and here carbon number 2, OH group. Therefore, these are called positional isomers. Means positional isomers of propanol are positional isomers of propanol are. So answer is propane 1 on and propane 2 on. Or common names N-propyl alcohol, isopropyl alcohol, because this group, all the 3 carbon states here normal. And this one, yes, CH3CHOH, CH3, or CH3CH, CH3 here, OH here. Right. Both are correct. Then this group named as isopropyl. That is iso. Then both are propyl, N-propyl alcohol. And the second isopropyl alcohol, N-propyl alcohol, isopropyl alcohol. Yes, these are common names of simple alcohols. Then iocyanine as alkanol. Yes, number of carbon here 1 methane, methanol, ethane, ethanol, propane, propanol, propane, propanol. But first 2 compounds, methanol, ethanol, CH3OH, methanol, 2 carbon, ethane, but last ending E. Example, methane, last ending E replaced by all, methanol. So like that, replace ending E by Y for alkali groups. Now, here, as I told, these to exhibit isomerism, hence right numbering. So this compound name, propane 1-ol. Propane 1-ol or 1-propanol. Propane 1-ol or 1-propanol. Next, propane 2-ol. Propane 2-ol. So propyl alcohol exhibit 2 isomers, and they are position isomer, but not functional or metamerism or what tautomerism. They can exhibit only here. These 2 compounds exhibit position isomerism. Right. Next, remaining compounds, compound number 5, that is having 4 carbon. If it is C4H9OH, C4H9OH is butyl alcohol. So there are 4 alcohols, butyl alcohol, 4 alcohols, and 3 ethers. But total we can exhibit 7 isomers. Anyway, butyl alcohol can exhibit isomerism. They are functional isomerism, chain isomerism, and position isomerism. And all the 3 types we can study by taking butyl alcohol with isomerisms. Compound number 5, CH3, CH2, CH2, CH2OH, 1, 2, 3, 4, C4H9OH, butyl alcohol can exhibit 4 isomers, CH3, CH2OH. Then CH3, CHOH, CH2, CH3, 1, 2, 3, 4. Last CH3, COH, CH3, CH3. Yes, these are the 4 alcohol molecules having the same molecule now, C4H9OH, and in all the cases OH group. Hence, here we can say compound number 5 and 6, they differ by position. See here, carbon 1, carbon 1. They differ by what? Carbon chain, not position of OH. Hence, these 2 are called chain isomers. Next, here, position 1, 2, 3, 4. Here also 1, 2, 3, 4. 1, 2, 3. But here difference is secondary alcohol, tertiary alcohol, secondary alcohol, tertiary alcohol. But here carbon chain straight, here branch. Again this is what chain isomerism. It can exhibit chain isomerism. Chain isomerism, chain isomerism. Okay. Then position 1, 2, 1, 2. Second position, second position. Okay. Anyway, these are the 4 alcohol molecules using the molecular formula C4H9OH, and the remaining 3 they belong to ethers. An ether molecule we can write like this: carbon, oxygen, carbon bond. This type of molecules are said to be ethers. Now using this formula C4H9, C4H9, 3 plus 2, 3 plus 2, 5. See here, C4H9 plus 1, H10, C4H10, O. This is ether molecule, and we can write other examples using this formula. One side CH3, other side CH2, CH2, CH3, CH3, O, CH, CH3, CH3. Yes. Now you can see they differ by here straight chain is branch chain. Here 2 carbon, here 3 carbon. Means all these are isomers. But nomenclature of ethers etc. will study afterwards. But these are the formulas. Means 3 ether molecules and 4 alcohol. Total 7 isomers are possible by using C4H9OH. But butyl alcohol exhibit 4 isomers. They are N-butyl, isobutyl, secondary butyl, and tertiary butyl. So these are the simple ones. Next, common name and IUPAC name of all these. N-butyl alcohol, isobutyl alcohol, secondary butyl alcohol, and last tertiary butyl alcohol. Common names. Next, IUPAC names. Yes, in all the cases you have tried numbering. After numbering, write the name. 4 carbon group, straight chain, okay, butane, and position 1 OH, therefore it is called butane 1. Second, position 2 methyl, 2 methyl propane 1. 2 methyl propane 1. Next, position 2 OH. This is similar to compound by butane 2. Butane 2. And last, tertiary butyl alcohol, common name. Its IUPAC name is 2-methyl propane 2. 2-methyl propane 2. Make it in 1 more question. Write the IUPAC name of tertiary butyl alcohol. So write yes, 2-methyl propane 2. 2-methyl propane 2. It is the IUPAC name of tertiary tertiary butyl alcohol. So this is about butyl alcohol compound. And I'll write one more example. There is a pentyl group. CS3C, CH2OH, 5 carbons, but it seems to be tertiary alcohol. But don't think it is a tertiary carbon. No, because OH group linked with CS2, not with C. Therefore, don't say it is a tertiary alcohol. It is actually primary alcohol, because there is a CS2OH group, but not COH group. Therefore, it is called primary. Okay, this structure, if you see the structure, is important. ONCS2. Just to refer this structure and write the name. So it is actually primary alcohol. Its common name 1, 2, 3, 4, 5. Pentyl. 5 carbon pentyl, and C here carbon is called neocarbon, because one carbon is only 4 carbons. That is said to be neocarbon. The total carbon 5. Neopentyl alcohol. Common name neopentyl alcohol. And IUPAC name, again numbering from this one. 1, 2, 3. 2,2-dimethyl propane 1-ol. 2,2-dimethyl propane 1-ol. 2,2-dimethyl propane 1-ol. That is the IUPAC name of neopentyl alcohol. Now about ethylene glycol and glycerol, and there in the classification I covered name for ethylene glycol ethane 1,2-diol and glycerol propane 1,2,3 triol. For glycerol propane 1,2,3 triol, and already I discussed the nomenclature of dihydric and polyhydric alcohols. Then same thing means we can continue for what ring systems. If it is a 5-membered ring, it is called cyclohexane. One of the H replaced by OH. Sorry, this one. A 5-membered ring is called cyclopentane. And here one H is called OH. Therefore, it is called cyclopentanol. Cyclopentanol. If there is a methyl group, then you write numbers 1, 2, 3, 4, 5. Now this becomes what? 2-methyl cyclopentanol, because number 1 is given to ONC, not CS3C, according to priority in the functional group series. About functional group and priority nomenclature, all we have studied in the first year. Okay. And same thing here repeated. 2-methyl cyclopentanol. 2-methyl cyclopentanol. If it is 6-membered ring, only this 6-membered ring, cyclohexane with OH group, all, therefore it is called cyclohexanol. This is to be cyclohexanol. Yes. Even for cyclic system, yes, you have to use cyclo as prefix before the root word. Methyl, pro, bute, pent, hex, etc. So before that, you have to use what? Prefix cyclo in case of cyclic alcohols. What are alcohols, how are they classified, and how to name alcohols according to common system and IUPAC system. Now write some formulas and try to name these, maybe primary, secondary, tertiary, or aliphatic, aromatic, etc. CS3, CS2, OH, CS3, CH, OH, CS3, C, OH, CS3, CS2, double bond CH, CS2, OH, benzene ring, CS2, OH, CH2, double bond CH, OH, These are the compounds 1, 2, 3, 4, 5, 6. There are 6 compounds. And according to the concept, whatever I told, based on that we can answer. So first question is, indicate among the 3, 1, 2, 3, yes, as primary, secondary, tertiary elements. And how to identify primary, secondary, tertiary, that also I explained. If a hydroxyl group linked with the CS2, then carbons, then it is said to be primary. OHCH group, secondary, and OHC, tertiary. Therefore, according to this concept, yes, OHCH2, primary alcohol, OHCH, secondary alcohol, OHC, tertiary. Primary, secondary, tertiary. Next. Compound number 5, it is said to be benzylic alcohol because there is a CS2 with carbon or carbon benzene ring. This carbon directly attached to it. Now it is said to be benzyl. Therefore, it is benzyl alcohol named as benzyl alcohol. Now, IUPAC is phenyl methanol. Phenyl methanol. Next. CS2 about CH, if OH directly linked with sp2 hybridized carbon. Here sp3 carbon, sp3, sp3, sp3. Even here also sp3. But only in this case, OH linked with C double bond C, direct linked with C double bond C. It is called phenylic. It is vinyl alcohol. 2 carbon ethene OH or ethanol. It is called ethanol, vinyl alcohol. It is vinylic alcohol, benzylic alcohol. Next, OHC, then C double bond C, this is called allyl. Of this group named as allyl group, OH alcohol. Allyl alcohol, vinyl alcohol, allyl alcohol, alkyl alcohol, benzyl alcohol. See here, vinyl alcohol, allyl alcohol, alkyl alcohol, benzyl alcohol. Is all these covered with common names, IUPAC names, formulas, etc. And then we can study what it's a preparation of some compounds like ethyl alcohol, methyl alcohol, maybe primary, secondary, tertiary. How to prepare all these compounds? Preparation of alcohols we can study in next week.